Hello, everybody. Today we're going to be talking about acceleration. This is this one right here, acceleration equation. And before we get into that, I want to talk about the experiments that we've kind of done so far. So the first experiment was the constant velocity experiment with the cars, right? And you found out, if you did the lab correctly, that it was linear. And we got a equation out of it, that distance is equal to the velocity times time. And then we used that and practiced it. Then you did a mini experiment. And by mini experiment, there wasn't a video or anything. You just kind of went through the experiment process. And that was the free fall mini experiment. And you found out that was linear, okay? And so, and that one gave us the equation that velocity is equal to acceleration times time. Now, the last one is the ball on ramp. So if you've done this, this is 2.5 ball on ramp, you should have found out this is quadratic, and this is the equation, all right? So it's quadratic, that gives us the squared. Acceleration, if any time is something that's falling, that acceleration is gonna be 9.8 meters per second squared. And then 1/2, and then this d is equal to the distance. So today we're gonna be talking about using this one right here, okay? All right. One thing I really want you to pay attention to, though, are the axes of these. So right here, time is on the x-axis. Now, usually independent variable is always on the x-axis and the dependent variable is on the y-axis. But whenever we're using time as one of them, time is always on the x-axis, okay? On this one right here, we had distance, time and distance. Here we had velocity, speed, and here we had distance again, okay? So when we're talking about acceleration, time, and distance, it's quadratic. But when we're talking about time and velocity, then it's linear. Cool, let's practice using this one right here for a little bit. So this is the equation. D is equal to 1/2 times acceleration times t squared. Okay, D is distance traveled, A is acceleration. And unless I'm giving you a problem where it talks about like cars and and different types of accelerations, you can assume it's 9.8. And time traveled is t. Okay, so if this was the ball and ramp, this would be how long it traveled on the tube. This would be 9.8, and this right here would be how long it took to get down the tube. Cool, cool. So let's do example problem number 1. This is probably the most straightforward of all of them. So here are the exact same steps that we're using from a while ago from unit 1, okay? And this is the example problem. A ball is rolling down a ramp for 4 seconds. How far did it roll? Okay, so step 1, underline right here the important information. Okay, that's step 1. Step 2, identify what the problem gives you and what it asks you to solve. Okay, well, it gives me 4 seconds, and then that's it, right? And asks me, so how far? So that should be a question mark, but what's acceleration? Oh yeah, acceleration is going to be 9.8. Okay, next thing is write the equation that you'll use. So there it is. Step 4 is substitute in the information that we know. So 4 goes in for time, 9.8 goes in for acceleration, 1/2 stays as 1/2, and d stays as d. Now we're doing the algebra. So if you remember in PEMDAS, the first thing that you should do, if you can, is the exponent, so 4 squared. Now 4 squared is not 8. A lot of students make this mistake. They go, oh, 4 times 2 is 8. No, 4 squared is 16. So bam, 16. Now I just need to multiply these 3 numbers together, and I get 78.4 meters. Now the last step, and I want you to do this on the homework as well, is write the final answer right here with the correct number of significant figures and the correct units. So the units is meters, but let's look at the number of digits I should write. Well, this measurement has 2, and this is a constant, so my answer should only have 2 digits. So bam, 78 meters, okay? So that equal, I need you to show your work and put in the units on the homework. I know it's a little tedious and you have to format it and this and that, but it makes sure that you're doing the work correctly and not just writing down numbers. Now, example problem number 2, okay? In example problem number 2, the ball is rolling down a ramp for 10 meters. How much time does it take? Well, 10 meters goes into distance. 9.8 is still the acceleration. You can assume it's on Earth, and the time, that's what we're solving for on this one, okay? So there's my equation. Substitute 9 in for A and 10 in for D. And when I do that, I get t all left alone. So the same setup, but the algebra is going to be a bit different on this one. The first step I'm going to do is multiply 1/2 times 9.8. That's 4.9, okay? Now the next step is I want to get t squared all alone on the right. So I'm going to divide both sides by 4.9. So when I divide this side by 4.9, this goes away. And when I divide 10 by 4.9, I get 2.04. Now the last step is I have t squared all left alone on the right. And so I'm going to take the square root for both sides. And so I have to use my calculator for this one. So if I were to do something like this, I'm going to go 10 divided by 4.9. That's this problem right here. And then I'm going to take the square root right here, and I get 1.43. Now again, two digits. This needs to be 2 digits, and we're talking about seconds. So my final answer is 1.4 seconds. This is probably the hardest of the example problems. The last one is, in this case, we're solving for acceleration. So in this case, you can say, oh, we're not talking about something falling, we're talking about something accelerating, like a car at a stoplight. So a car at a stoplight, you can assume it's stopped. Then the car turns green, and then let's say 5 seconds later, it has gone 10 meters. We need to figure out what the acceleration of that car was. Okay, cool. So distance is 10 meters. Time is 5 seconds, and we don't know what the acceleration is. So same exact equation, plug in what you know. So 10 goes in for distance, 5 goes in for time, acceleration stays at acceleration. Now again, the next step is the exponent. So 5 squared is equal to 5 times 5, which is 25. Now what I'm going to do is I'm going to multiply 1/2 times 25 to kind of put those together on the right side, and that's 12.5. So 1/2 times 25 is equal to 12.5. Now I'm going to divide both sides by 12.5. That will get rid of it on this side and give me 0.8 on this side, and that's my acceleration. And that's perfect. Bam. So today's homework, which you can find right here, actually if you're watching this already right here, it's this one right here, and you can get started. Okay? Please let me know if you have any questions. Another thing is on Thursday this week and on Monday at 10 a.m., we will be having live Zoom meetings. So if you want questions, if you have a review, if you need information, if you just want to check in and go over the review, that will be an option. Take care. See ya.